So I thought I'd start today with this from the Research Council of Norway. They now state in their guidelines that all projects that receive funding from a research council must follow the FAIR principles as much as possible. So in the run-up to this project proposal, I received probably dozens of emails from people asking me, how do I make my data fair? Or I've written this to go in my proposal. What do you think? Is this fair? Is this good enough? Will this help me stand out from the crowd? It seems to me that fair has become a bit of a buzzword, unfortunately. People say they're going to publish their data fair or fairly, but perhaps don't fully understand what that means. And if you look at how people plan to publish their data, often the plans aren't fair at all. So I could spend the rest of the presentation going through the FAIR data management principles, but instead I'm going to simplify this. And all it really comes down to is three things. The data centers you publish to, the file types you use, and the conventions that you need to follow within the files, and the conventions that the data centers follow, although you don't really need to interact with those so much. And if you follow these recommendations, and what I'll explain today, your data will be fair. So, what makes a good data center? Two things. Firstly, they want you to make sure that they're going to look after your data for a long time and it's going to be secure. And secondly, that it's easy to find and also use. So, in terms of security, what can you look for? This is a bit tricky and you have to look into the terms and conditions, I suppose, but as a good rule of thumb, you should look at where the funding is coming from. National data centers that are funded essentially by the taxpayer. This is more likely to be a reliable source of funding if we look forward decades into the future. Whereas if you're putting your data with a private organization, it might be that organization goes bust, and maybe they have a plan for what happens to your data if that happens, maybe they don't. And there are good international data centers, but as a good rule of thumb, publish to Norwegian ones wherever you can, with some exceptions. The next thing is that the data should be easy to use and find. This is a bit more complicated. Quite often when I'm reading through papers, I see this. And you might ask, what's wrong with just saying in a data availability statement that the data are available in your supplementary material? I mean, someone can find the data. Depending on how you've done this, it could be secure. Technically, it is open access, but what I will come on to is that open access isn't really good enough for data. And the problem here is that kind of missing the bigger picture. The data should be useful by themselves. Someone who's never read your paper and who's not aware of your paper should be able to find your data. And while your paper might be read for a few years into the future, maybe a few decades if you're really lucky, your data, if you publish them fairly, could be used for much longer than that. And you might say, who's going to care about my little data set that I've collected up in the Barents Sea or something like this? Who's going to be looking at this in a few decades' time? But you shouldn't consider your data in isolation. Your data might be the beginning of a much longer time series of data that you might be collecting yourself, or perhaps other colleagues might be going back to collect. And if you think whatever parameter you're looking at is interesting, the chances are someone else in a different area in the world will also be collecting a similar amount of data. So you can think of your data as a contribution to a much larger collection of data that someone might be interested in downloading and accessing together. And in some cases, with some types of data in data centers, it's already possible to hit a download all button and take data from multiple data centers or from multiple data sets and pull them all into a single file that you can use. So more specifically, what makes a good data center? Well, they should provide your data with a DOI. DOI looks a bit like this, and if you click the link, I hope this works. Yeah, whatever. This way. Yeah. Then you will have your go to the landing page of the data and where you can download them from. If you are sharing around your data, and actually this comes back to publications as well, is it's much better practice to share around the DOI than it is to copy and paste the URL. And this is the same with your papers. The URL is liable to change in over a time span of years or something, whereas the DOI is persistent, that will stay constant through time. So even if a landing page changes, URL changes, you'll still be able to direct back to your data. It should also be easy to find your data within the data center. And this is some point that people overlook quite often. So a good data center should work a little bit like booking.com, or at least it should look like this. You can imagine that a single hotel in this analogy is like a single data set, or perhaps a single room is like a data set. And booking.com is useful because you can search for a hotel based on where it is in the world, when the rooms are available, and certain amenities and things like that. Now, this is only possible because someone from the hotel has registered that hotel with booking.com, just like a researcher might register their data with a data center. And it's only searchable in such a way because booking.com has requirements and says if you don't provide this metadata, then we're not going to host your hotel on our site, basically. So we can actually test this whenever you're considering whether a data center is any good or not and how visible they're making your data center. The best thing to do is just go to the data center and test this out. So I'll show you a couple of examples. One data center that's gaining a lot of traction is Zenodo, and I get asked all the time, well, everyone is publishing their data to Zenodo, so it must be a good place to publish their data to. But I would say that that's not really a good argument, and Zenodo isn't really a data center. It accepts a wide range of things. You can publish articles to Zenodo, you can publish code to Zenodo. Anything you want to get a DOI from, it's actually good for those things. But it's not a good place for data because you should be able to find the data. And not just via the DOI. So let's do a bit of an example. I'm going to have to move my shoulder here. If you are interested in seawater temperature data, you return with this. The first item that comes back doesn't really look relevant. Second one neither. So you might think, okay, well, let's filter further. Let's try and refine our search. What can we do? We can look by access rights. Well, this won't tell us anything about the data. File types, some vague keywords. None of them are really relevant either. Or the type of thing you're looking for. And that's it. So it's very difficult to be able to find data that have been collected in a certain region or data from a certain year or from a certain author. You only have this free text search and a couple of fields. So I think Zenodo is really gaining a lot of traction because it's easy to publish your data to it. There's not a lot of requirements for the user, but you should ask why that is. A good data center will not necessarily be the one that's easiest to publish your data to. Dryad is kind of similar. Dataverse is a bit better. It's at least trying to be a data center, but I would advise publishing against publishing in there as well. Probably the best example of a service that's been built on top of a data center, on top of data, is provided by GBIF. And if what GBIF is a collection of biodiversity data where you have, okay, we have this section, blah, blah, blah. We have a collection of occurrences where a single occurrence is a single observation of some species, whether that be an animal or a plant or anything like that. Just looking for something that I need to copy from here, forgive me. So what you can do on GBIF is you can take the scientific name for a species. I can take this, Plectrophoenax nivalis, which is the snow bunting that will be returning in a few weeks' time. Hit occurrences. I only want these ones. And you get a map of all the occurrences of observations of this anywhere in the world. And this isn't just from a single data set. You can see here, this is compiled from a number of different data sets. You can do some on-the-fly analysis here. You can look at, okay, where do they go in the winter when they're not here? And see this. Whenever you're finished with it, go to download. Okay, I can do this. I think I'm looking with Facebook. No. Basically, you will get to a page that tells you you can download all of those occurrences into a single file. Once you're logged in, hopefully I won't waste time doing that now. Another data center that more of you might be using is the Arctic Data Center. This is meteorologically. You're going to find data here. And you can see on the left and right-hand panels, you have a number of different filter options, finding different data, and you can find things on the map as well. So this is kind of how a data center should be aiming for it. This is nerd. I'll come back to those in a little bit, but this is also quite searchable. Should also consider that some people are going to want to look at this on scale. This is nice to have these interfaces, but some people want to look using an API for different files. If you're one of those people, consider that too. So you can find the data within the data center, but there are hundreds, if not thousands, of different data centers to choose from. And it's not really efficient for the user to go and search through all of them if they're looking for some data. So it's important that the data center itself is interoperable. I'll show you an example. Imagine this is Trivago, which is, for people who are not aware, it shows you where the cheapest option is for a hotel, whether it be booking.com, hotels.com, or something like this. And this is only possible because all the contributing websites have a common set of metadata. So they follow some kind of standard that Trivago can understand, and therefore Trivago can also include filtering options based upon the same things. This is a little bit how the SIOS data access portal works. So SIOS don't store any data. They just point to where the data are elsewhere. Again, it's searchable. It looks like this. I'm not going to go too much into this right now. But the UNIS policy should be that we should be publishing data that is relevant to Svalbard and therefore should be available via this access portal, which aims to provide access to all data centers and all data that are relevant to Svalbard in one place. There's a list of data centers we can look at on here. scroll down. A lot of these are associated with an institution. One exception, which is useful for us, is NERD Research Data Archive. This is funded by the Research Council of Norway. For now, it is free to publish all of your data to this, and you can go ahead and use that. If you have collaborators in some different institutions, you can use the other data centers as well. If it's a particularly large data set on the order of terabytes, there might be a small charge because it becomes expensive to keep those data on the order of decades. But otherwise, it's more or less free as well. So if I'm working with some marine data, perhaps I want to store them with IMR's data center, for example. Yeah. And then another thing I get asked a lot is, well, what about this data center? This is where everyone is storing this type of data. And that's good because you want to publish your data somewhere where someone's most likely to look for them. So that's good. But my advice would be is you should always evaluate these other three things first. If it gives your data a DOI, if it's easy to find the data within the data center, and if the data center is interoperable, then having data that is a default for a certain type of data is a good idea. And there's some examples that are specific to different things. If you want me to evaluate one, just let me know and I'll have a look at it for you. But there's GBIF, GeneBank, things like this, which are all quite good. So we've made our data easy to find, but are they easy to use? Is it possible to create a function like this, where you can download this all into the same file? So that comes down to file types. What makes a good file type? And the question is, what is the goal here? Is the goal that you, who created the data, can easily access those data and get them into the format you want? No, because you already have the data on your computer. You can continue to use them however you like. Is the goal that other people at UNIS can easily access them? Well, no, because they can easily contact you and they can get the data in whatever format you like them to be. The goal is long-term archiving and use so that the data will be understandable for someone on the other side of the world and for someone in several decades' time. And also, so someone can build services on top of the data. We talked about how we can combine data sets into one. Another example is you might be able to visualize data on the fly. And this is something that's newly been introduced by SIOS for time series of data in some cases. So if you're publishing a NetCDF CF file, like this one. I've gone to this single file that I know this works for. In some cases, you have this little button here, Visualize Time Series. You can click this in a few seconds. It will plot the data for you. And we should remember here that SIOS doesn't store any data. It's just providing you with access to them and displaying them through there. You've got multiple variables. You can select which one you're interested in. You can resample the data. Maybe you just want weekly values. You can zoom in, something like this. And after you're finished, you can download them, get the raw source data in a NetCDF file, or you can download it to CSV. So just because you provided data in a NetCDF file doesn't necessarily mean that you have to interact with them in this way. You can download the resample data as well. So things like this are becoming more and more possible. And with data, we should not think of just what's possible now, but also what's going to be possible in the future. So what makes a good file type? Firstly, it should be software independent. So an Excel file is not software independent, a CSV file is. It should be standardized. So if we imagine that we're on a ship and we're measuring the dimensions of different ice flows, I might measure it, record this like in the red box. Someone else might record them as in the blue box, and someone else might do it like this. I understand what all three of these mean. I created all these tables. Maybe you understand what they mean too, I don't know. Would you be able to write a script that reads all of these in and treats them all in the same way? Would anyone? And would they be able to do that if there's 1,000 different iterations of how those files could be structured? The file should contain metadata within it. So you'll provide data to a data center and they will have some metadata as well, but also the file should contain the metadata. That's useful for a few reasons. Firstly, I download a file, I send it to someone else via email. They then also have the metadata too. Also, you don't have to keep referring back to the landing page. And it should be self-describing. So not only should it be standardized, but also there should be, it should say within the file what standard has been followed and how the data is structured. Not only should it contain metadata, but it should have follow a standard that tells me what each of those metadata terms means. So that not only a person, but a machine can also understand the data. Lucky for you, there's only two options really in most cases. There's Darwin core archives. These are mainly if you have a species list. So mostly relevant for biologists, but if any geologists have a list of fossils, they can also use this as well. You can also put other data within this. So if you have traits or measurements related to those species, you can put them in here, like the weight of a fish or something, whatever biologists are into. And anything else, environmental measurements, temperature of seawater, wind speed, anything like this can go in an .etcdf file. And this should also include model data as well. So if you're getting data output from a model, you can put that in an .etcdf file as well. Quick example of what these look like, if you've not seen one before. It should be a lot longer than this, but I've put this all on one page. So there's a dimension at the top. This tells you that we have 3 points of latitude in the file, 4 points of longitude, 2 points of time, but more might be added later. So this tells you about the shape of the data. It doesn't tell you anything about what those values are. It tells you about what the shape is. We then have the variables. So we have this latitude variable that has a latitude dimension. And you have some variable attributes which tell you about the metadata about that variable. Then we have this rainfall. And this has 3 dimensions, time, latitude, and longitude. And this is an advantage of .etcdf files in general over something like a CSV file. A CSV file is somewhat restricted to one dimension. You can obviously, there's some workarounds, but usually you'll have to restructure it if you want to get it into a 3D grid, whereas .etcdf files really specialize in storing multidimensional data. You then have global attributes. This should be a lot longer than this, but one thing I will point out is that it tells you what conventions have been followed within the file. And then the data goes at the bottom. More extensive and realistic version is something I created here. Main difference is you have far more variable attributes in this case, and far more global attributes. So how do you know which attributes to put into these files, and how do you know how to structure this? This then comes to conventions. I'm almost running out of time. So we have the CF conventions, which will tell you how to structure the file. This is a long document. Yeah, through all of this. I don't think anyone has read all of this, but it's you could think of this like an encyclopedia. If you want to do a certain thing, you want to structure some data in a certain way, you can find whatever you need to do in here. So for example, let's say I have some depth data, a depth profile. I can come here. I can see some examples of how I need to structure that netcdf file. We then have the ACDD conventions, which tell us about the global attributes, which is then a list of terms. I will actually go to this one below, actually. So SIOS has certain requirements, and they are in line with what the Arctic Data Center requires because it's managed by the same people. So if you go in here, you can see a list of all the attributes you need to put in, whether they're required or optional, and some description of how you should fill that in. Then have some GCMD keywords, which are, this is a really important piece of metadata because one thing that people will want to filter by is what type of data is, and this is where the keywords come in. So then you can take them from a common list of terms. They're searchable here. This takes a few seconds to load. But then you can go in and find perhaps earth science, oceans, whatever, and find this. And then you put the whole string down to here. I'm not going to go through this very briefly, but this is to give you a flavor of how things work, and you come and ask me when you actually do it. But yeah, this is how this works and why we use that. One thing some extra add-ons I wanted to show you. At Lanson Legacy, we've recently included this web page on the new website. This points to all of our most in-demand data sets. This would be a cool thing for UNIS to have an equivalent of, in my opinion. It looks a bit like this. So we have the CDD data, chlorophyll data. What I really want to show you is this OpenDAP. So I often recommend people divide their data into cruisers and then into stations, but basically so you're having a single data set being a single location and publishing lots of data sets rather than a single file. Makes the file simpler and easier to use. But then you can take a URL of something like this, put it into your Python or R script or whatever you work with, and read them all in. OpenDAP works by allowing you to access the data as if they are stored on your computer. So you don't have to download them. You just put the URL into where you would normally put your file path and download them all. You can also go through here. Let's say you're interested in just pressure, temperature in this case. You can take a subset of this if you want just first 200 values, I don't know. And then you can get the data out as an ASCII file. So even though they're stored in netcdf, you don't have to interact with the data in that way. Finally, something that's in the news a lot at the moment is ChatGPT. Most of you may have been working with this and trying it out for yourself. But did you know that you can ask it to write a Python function that creates a map of global seawater temperatures for any given day? And it will do this for you. The function it provides is a bit longer than this. But what's really cool, and why I want to show you this, is that what it's been able to do is identify where the data are, identify what the data is, and also how to interact with them, and it knows what latitude is, longitude is, what the temperature is, and it can do something useful with them. We don't know where we are in the development curve of AI, whether this is the start of things to come, and we will look back at ChatGPT like we look back at search engines from 20 years ago. But this is going to revolutionize how we interact with data, and this is going to make it a lot easier for you. to get data as a data user rather than a data creator in the future. But if ChatGPT or other AI is going to understand your data, you first have to publish them fairly. If you want some help with this, I host a YouTube channel. Most of you probably know that already, but you can scan this and subscribe. There's information on how to create .NET files in different languages, create in Darwin core archives, how to do it without any coding. This is just a program you can use here. It'd be, in my opinion, really good if we had a data policy and data management plan, so we have all this written down. I hope you will remember what I've said today, but probably it would be useful to have this documented